Hi, my name is Richard O'Sullivan from SoundCam UK, your UK distributor of the SoundCams from CAE Software and Systems GmbH from German-made quality, made in Germany. I'd just like to give you an overview now about the different SoundCams that we sell, because you might want to know for your application which is the best one and what's the difference, and that's what I'm going to try and communicate. Good news is the software is the same on all of them, so what you can see behind me there on the screen you'll recognize on the other ones that I grab in a moment, hopefully. So basically we'll start from the one that we've got there. That one is actually the most flexible one in the range because it's modular. Why is it modular? Well, it's modular because, if I manage to turn this around, you can see that the microphone array on the front is actually magnetically held, so I can just pull one off like that, pull a branch off, and I can fit a smaller one on or a bigger one on. So this one is a kind of somewhere in the middle of the range one. This is an M, the M arms, which it's like t-shirt sizes actually. You have XS, which I'll never get into ever again in my life, I'm afraid. Well, why? Why do we want modular? Why do we want different sizes? What's the point of all that? Well, the point is, as Mr. Scotty used to say on Star Trek, you cannot change the laws of physics. Sorry to everyone from Scotland, I can't do a Scottish accent, but he was trying to tell you that you can't get round the laws of physics. And the laws of physics, in this case, are beamforming. We're using something which comes from like finding airplanes in the sky or whatever, radar type technology. We're using the same mathematics. So we've got all these microphones, and the reason we're talking about the diameter of these things is because the biggest diameter of the microphones, the furthest spacing that you've got, determines the lowest frequency you can locate. So the smallest XS array has a diameter of 28 centimeters and a frequency range of 850 Hz to 24 kHz. So it's the lower frequency range due to the small size that starts at 850 Hz. The next size up, the SoundCam Bionic S array, has a diameter of 54 centimeters, and that gives it a frequency range starting from 480 Hz to 24 kHz. And then we have the Bionic M, which is the one we've been standing next to the whole time, has a diameter of 100 centimeters, 1 whole meter, bringing its lower frequency down to 250 Hz, and of course reaching 24 kHz. The L array is the largest in the family, the SoundCam Bionic L array, having a diameter of 170 centimeters, and that means its lower frequency range, or its lower limit, is 150 Hz, going up to 24 kHz. So that's the Bionic modular. It's modular in terms of hardware. It comes with the same instant software, so I call it instant because it's giving you beamforming on the screen as we speak. So it's live on the screen. If I put a sound source on here, then as soon as my mobile wants to do it, there we go. It'll. I can see that on the screen. It's a bit small for you, I'm afraid, but live on screen, it will do at 100 frames per second. It'll find sound sources. So if sound is bouncing around or it's actually traveling through the structure of something, it started at a stamping machine in the middle where the stamps come together, and it's traveled through the structure and it started to make the machine waddle about. Although you can't see it's microscopic, but the actual panels are radiating the noise. So you can see sometimes some very interesting things, which panels you might need to treat that will actually reduce the noise. I've got a good example of that on another video. So have a look at my channel and you'll see an amazing example of watching the sound travel through the structure, and gives you an idea that actually treating that structure rather than the stamping operation itself will give you the first nearly 10 dBs of sound reduction. So it's not what you think, it's not as obvious as you think sometimes, and it's these tools, they'll bring you to solving problems, to problem solving solutions for your machines and the things you're developing much faster than was possible before, because we can actually see sound, and that just really wasn't possible before. It's something new. It's a new way of working with acoustics, but you don't actually have to be an acoustic expert, because our software is touchscreen, and I could teach anyone to use it in half an hour if they can use a mobile phone, which most of us have learned to do by now. Okay, so what about the other ones? The next one in size down, I'll say, is this guy. This one is the SoundCam 2.0. You can see rings of microphones, 1, 2, 3 big rings of microphones, and then inside the 4 big blobs are the LEDs, so you can light things up, and then the camera's in the middle. So this one's got 64 microphones in about, I think, 34 centimeter diameter, and its lower frequency is similar to the XS in there, around 800 hertz. And it goes up to, actually this one now goes up, because it's a 2.0, it goes right up to I think 60 kilohertz cut off. So it's in the ultrasonic range. You can actually find leaks and electrical discharge and stuff with this as well. In fact, the Scottish Electricity Board are checking the integrity of their insulators with these guys. So as you see, exactly the same software, so it's all one family. There's a video coming up on my YouTube channel, which is going to go through this software in detail. We've already got some on there, but I'm going to do an update because there's loads and loads of extra features that they've included to do all sorts of clever stuff. So hold on to your hats for that one. Okay, I'll show you the little guy of the bunch, and I'm not talking about me. I'm only little in one direction. This guy is the little guy, and it's the SoundCam Ultra. Now, small is sometimes desirable. In my case, always. Small is good because, again, it's a law of physics thing. Not only does size determine the lowest cutoff, but if it's smaller, it's going to give you a better dynamic range in the higher frequencies. So its responsiveness, if you like, in the high frequencies is enhanced by having a smaller array. So this guy we actually designed as the specialist for the very high frequencies, and he'll go right up to 100 kilohertz. He'll start at 2000, so you can still find sources at 2 kilohertz, but you can go right up to 100 kilohertz. So that's a frequency way above what we can hear. We can hear, well, I can't even hear up to 20 kilohertz these days probably, but your children can hear up to about 20 something kilohertz. And as you get older, unfortunately, it deteriorates, but most people can hear 10 kilohertz even when they're older, unless they've got real hearing damage. So just to give you an idea, up to 100 kilohertz is way above. Your dog can hear towards that area, but not quite as high as that. Bats' radar that they use to find out where the walls are and things, they are kind of in about, I think, 40 kilohertz range. But what this guy is good for, actually we've got somebody looking at bat movements and stuff like that with this as well. But what this is mostly used for is finding leaks, gas leaks. So if you've got compressed air in your factories, running miles down your factories, gas leaks in gas distribution systems, whatever, you can wander about the factory and find these really fast. You'll see them from 30, 40 meters away. It's very, very sensitive. And the good thing is that the range that we're looking into, which is like 30 to 60 kilohertz or something, is way above what all the rest of the noise is in the factory. Most of the rest of the noise in a normal factory. So these leaks stand out, and they're not interfered with the other factory noise. You don't have to shut down the factory to find the leaks. So this is the SoundCam Ultra with the specialist for very high frequencies. So that's the third one in the range. Now there's two more which basically belong to the others, so they're not particularly totally new. In fact, they are new on the market, but this one here is the Ultra Sensor. So you can see it's got a very similar array to the SoundCam Ultra that I just had in my hand. Turn it around, there's something missing, it's the screen. So it's actually got the innards of the SoundCam Ultra, but not the screen. And it needs power and it needs network, and you connect it to a remote PC. and then you can have exactly the same software on your PC. Now you can do that actually with all of these models if you want to remote control them for some reason. But if you're fitting this one permanently on the wall somewhere and using it to look at your critical production machinery or your distribution board for your gases or whatever, to make sure that no leaks come up, or whatever you want to monitor long term, this guy would be better because it's robuster. Basically, this is made of solid metal, and you can crash into it with something and it's not like to get damaged. And it doesn't need a screen on the back, so why have something else that can break down? You're just looking at it remotely. So that we've had them on the front of robots that are moving around looking at stuff. There's actually another sensor as well. There's another model which is bigger than this one. It's actually got the same array as the SoundCam 2.0 that I just showed you, the bigger guy. I'll pick him up again, just get some exercise. No, it's not too heavy, but it's basically this same array but without this part on the front. So it hasn't got the controls and the screen on the back, which it doesn't need because it's again mounted on the wall doing long-term monitoring. So depending on your frequency range, you'll choose one of the ones with or without a screen, and if you have to go down to low frequencies, I'm afraid you've got to go big. It's never going to be the case that you'll have a SoundCam, an acoustic camera built into your mobile phone that can do more than just show really, really high frequencies. It needs size. Size is important sometimes.